the third question. The third question is about making an outlier detection plot using the bounds based on the mean and the standard deviation. So here I clearly need to find outliers using the mean and the standard deviation. What can I do? I can first try to code the function from scratch and then call that function. Otherwise, I can directly go on the replication file here and try to find how the detection plot has been made for the slides. And so you see that here, this is the function to detect outliers using the mean and the standard deviation. How do I see that? You see that I'm using in that function Unc_mean, which is just the computation of the mean, and sigma, which is just the computation of the standard deviation. And then you can see that I'm computing the lower bound and the upper bound using the mean and the standard deviation. So clearly, this is the first procedure that we have seen together during the class, during the session. So now what I'm going to do, I'm just going to copy paste that function and I will put that into my Python code. And now I will select all this new function and I will press F9 so that it has in its memory, it has that function, and so I am now able to call that function below. So that's great. Now I can directly detect outliers using the standard procedure. And you see that I can just, as an input, I only need to set the input ret, which is an array, as I said during the session. And also, I also have to fix the quantile, so the percentage quantile that I require for the threshold, for setting the interval, so for setting the lower bound and the upper bound. So let's call that function. So I will just I will put all the outputs, I will set all the outputs into the variable output, and I will call the function outlier detection. And so I want to detect outliers in my array draws. And also I want to set a specific threshold. Here you can choose any quantile that you want. For instance, if I choose 0.95, it means that if I look at the standard normal distribution, there will be 10% of the observation that will be on average outside the intervals that will be created by this outlier detection function. Typically, we use the 1.96 threshold, so here it corresponds to 0.975, which means that we have 5% of the observation that are outside the intervals. Always think about the fact that you have the left tail of the distribution and also the right tail of the distribution. So the number of observations that are below the lower bound of the interval, and also the number of observations that are above the upper bound of the interval. So let's look at this and let's run the code to see if it works. So you see that I have pressed F9 and you see that in the console that it has worked. So that's great. So now I have in my output variable, I have three different things. So you see that the function outlier detection returns three different variables: lower bound, upper bound, and outlier time. So in my output, if I just press enter here, you see that I can just I can get the lower bound, I can get the upper bound, and also I can get here the third variable, which is an array, and which is the outlier time. So it means the the indices that are outliers in my array. So you see that it has detected the five outliers that I have added to my series, and also we have some outliers in the rest of the draws. So in the remainder of the draws. So that's nice. So now I can directly, so if I look at the question, so the question wants me to do a plot. So clearly I will have to use the package matlablib, and it asks me to make a plot about the draws with the lower bound and the upper bound. So I have the lower bound here, I have the upper bound here. So now what can I do? first I have to make a plot of the draws variable. So for instance, here you have, if you look at the replicate file for the slides, you see that I have exactly what I'm looking for. I have a graph here with some observation and a lower bound and an upper bound. So let's just take the code here and try to adapt it a little bit to see if I can end up with some graphic where I have the draws and the lower bound and the upper bound. So the first line here is just about creating the graph. So here at the end we just have a frame with an empty graph. It is always required because so that you have the size of the graph and so that Python knows that you are going to create a graph. Now, after that, here I'm just calling plt.plot. So plt is a short name for these packages here. You see that I am calling it as plt. Otherwise, if you do not put as plt, you have to call the package by just typing all these names. So it is clearly easier to work with plt. And then, so plt.plot, this is to create a plot. And so on the axis, the x-axis, I want to put some values. And then for the y-axis, here you see that this is red June. So clearly this is not the correct y-axis because I do not have any variable that has the name red June. So if I just run that code, it won't work at all, of course. So here clearly on the y-axis, I want to just show the draws. So I will put the variable draws there, but clearly x also does not exist. So if I run just x, it just tells me that the variable x does not exist. So what I have to do, if I want to have an x-axis, I can just create the x-axis, and the x-axis will be just the number of observations that I have. So I know that I have n observations, so n is a sample size, so I will just create an array of n observation. One way to do that is np.arrange. There is also the function range that allows you to do that. So if I look at my variable x, so you see that I have now an array that starts at 0 and then goes up to 504. So if you count all these observations, I have 505 observations. So now it should work, and I would be able to have an x-axis that starts at 0 and that goes up to 505 observations, and on the y-axis you will have the draws. Okay, so now what I want to add, I will want to add also the lower bound and the upper bound. So here you see that I'm going to add the lower bound and the upper bound. All these code here in between is not that important. So you see that here I'm just adding on the slide, on the graph, the unconditional mean, so the average of the variable, and this is not something that is required by the question, so you can do it, but this is not compulsory. So you can just delete everything, and so you are just going to add the lower bound and the upper bound. So again, here you see that it is related to red June because I have copy and paste everything from the replication file. So this is not correct because red June does not exist in my file here. So I have to change red June by draws, and I have to do that everywhere. So now I have the lower bound, the upper bound, and you see that after that I'm just plotting it, and I am just choosing the type of the line that I will have. So here, for instance, I'm just saying that I want a line. You can change it by just having a dotted line like this, for instance. Let's say let's do this, and then you can choose the color. So here this is in red. If you want more information about this, again, you can just type question mark and then plt.plot. And so here you will have a lot of information about how to perform a plot. And so, for instance, what you will see just below you will see, I think so, yes, here for instance you have the line style. So you see that I made a mistake, for instance. That's nice. So you see that if I want a dotted line, what I have to put, I have to put, I have to type this instead of what I have typed. So that's good. So you see that there are other types. So this is the line, this is a dashed line, and so on and so forth. So that's good. I think that you can also find the color, the different color, but just to give you some hints here, the color are, for instance, for the red, this is R, for the blue, this is B. This is just strange for black, this is K. For the green, this is G, and so on and so forth. Okay. So now, if you want a label, you can just change the label for the axis. Let's say that these are my draws, and here this is just the x-axis. And so now I just going to take everything here. So this is important here. If you do not take, for instance, plt.show, you won't see the graph. It will work, but you won't see the graph. The grid here, it doesn't matter. This is just a grid. I will show you the difference, but this is really not important. And typically, we do not have the grid. So let's say that now I take everything here, and let's try to see if it works. So that's the good news. It works. So there is a warning here because this is a new version of Spider. But what do we see when we look at this plot? We see that we have our outliers here at the beginning, and then we have all these other observations. We have the lower bound and the upper bound. So the grid is just here, the grid that you see behind the plot. So if you just delete that line, you will have no grid, and this is sometimes easier to read. So like this is also nice. So yes, so here again, for instance, if you want a scatter plot, one way to do a scatter plot is like this. Otherwise, you can call plt.scatter, if I remember correctly. And so here you have a scatter plot. So you see that I'm just saying that I do not want a line for every draws, so that here Python tries to interpolate the empty size, the empty bin between the different observation. Here, I just don't want that lines, and so at the end, where I just have the different dot where you have the observation. It's perhaps easier to visualize here the outliers when we look at this. So clearly we see that these five first outliers, the first five of outliers. So now you see that I have solved the third question.